Okay, so today we're going to be reviewing graphing exponential equations before your test. Your test should look just like this, same number of problems, same type of problems, that kind of stuff. Again, an exponential graph or an equation is going to produce a curved line, kind of like this, where it goes flat and then it starts curving up. And you know, when the pandemic started, they kept talking about flattening the curve. Well, it's because viruses spread exponentially. So what they are basically doing is trying to get this curve here to flatten and go back down. Okay? But exponential equations always start with what this little flat part here, which is called the asymptote. And when we're looking at the equation, that flat part always hugs the y value that's associated with that number that is adding or subtracting to your problem. So for here, like I can see that -2 should probably be where my flat part is on the graph. Now to graph exponential equations, it's not that tricky. We're basically going to do it in a way that we're just graphing ordered pairs or points. To do that, we make a table of x and y values. Now, the important part on a curve or on this graph of a curve is going to happen right around the origin here. So basically what I'm going to do is I'm going to pick the x values that go right around the origin. So -4, -2, 0, 2, and 4. And those are the values I'm going to use for my table. And I'm going to use those same 5 values every time, every single time, because that's what's happening right around the origin. And that's the important part for the graph. That's when it starts curving up. Okay? Now, the other part is going to be filling in the y values. To fill in the y values, I'm going to plug these x values in for the x into the equation. Now, your calculator will do all this work for you. Basically, you're going to write down the equation just like you see it. So I'm going to do parentheses and then fraction 1/3, parenthesis, and then exponent. Now, this is where I'm not going to put in the x. I'm going to put in the -4, right? And then I'm just going to basically take turns of switching out that exponent for these numbers here, because that's where my x is. So I want to just take turns switching them out to figure out what the corresponding y value is. Because whatever this ends up being when the exponent is -4 minus 2, that's going to end up being what my y value is, because y is equal to 1/3 to the x minus 2, right? So when I plug that in, push enter, I get 79. Ooh, that's going to be way off my graph. So I'm not going to actually graph that point. Okay, then I'm going to enter in that same equation again, but instead of -4, I'm going to put in -2. And then I'm going to push enter. And this time I get 7. Okay, that's on my graph. That's going to be fine. Okay, then I'm going to, again, put in that same equation, but this time I'm going to put in 0. 0, I'm going to delete the 2, and that's it. So then I push enter, and that time I get -1. Okay, and I keep doing this for each problem. Okay, and you can quickly copy these by just highlighting it and pushing enter, and it copies the equation for you. So you can go back and just change the one number that you need to. Like I need to change that 0 to a 2 now. Then you push enter. This time it's -17/9. I'm going to change that to a decimal. I'm going to round it to the nearest tenth, so -1.9. Okay, then I'm going to do the same thing with 4. And I get, -1.99. So again, just -1.9. Looks like it's going flat somewhere, right? So when I graph these points, -4, 79, that's clear off my graph. So I'm going to kind of forget that one. -2 and 7 would be like right there. Negative or 0 would be -1, so like right there. 2 would be at negative 1.9, 4 would be at negative 1.9. You can kind of see if I connect those, which side is going flat, right? It says right side is going flat, and it's going to hug negative 2 there because that's where my asymptote is. And then this other part is going to go clear up here off the graph, because I know like at negative 4 it's clear up at 79, right? So that's all you're basically doing for this unit, is you're just basically plugging in these numbers and graphing those ordered pairs. Okay, so negative 4, negative 2, 0, 2, 4. I'm going to do the same thing again for this graph right here. I'm going to pause it while I plug in these values so this video isn't a million minutes long. So hold on one sec. Okay, and like magic, it's done, right? So I went through and I multiplied it through. I got negative 4 times or to the negative 4 power, and I got negative 9.9. To the negative 2 power, I got negative 9.9. At 0, I got negative 9. At 2, I got 6. At 4, I got 246, so clear out the graph. So when I graphed those, negative 4 was negative 9.9, so it was negative 2. 0 was a negative 9. And then at 2, it went up to 6, and 4 was clear off the graph. So connecting those, the horizontal asymptote was right here at negative 10, and it was going up just like that. Okay, so not too tough. And then I went ahead and I entered in all the things ahead of time here, so we don't have to worry about that. So on this one, again, we start off with our same x values, and my lights just went off, so you get the creepy face in the corner there. 0, 2, 4. Okay, and then when you enter that into your calculator, again, you would basically just enter it as negative 3 times 2 to the, and you push the exponent button, and you'd start with negative 4, and then it's plus 8. So plus 8. So you just enter it like that, you get your value, push the fraction decimal button, 7.8 is what you're going to start with. Or yeah, 7.8. So 7.8 is what you would start with. And then you would do the same thing with negative 2, which would give you 7.3 when you do it. And then 0 would be 5. And then 2, you would get 0.1. And then at 4, you would get 0.01. Okay, so really small, really close to 0, basically. Am I doing this right? Yeah. No, I'm not. I'm looking at the wrong ones. Sorry. This didn't work. Okay, anyway, it would be negative 4. I was like, that didn't make sense. And then negative 40. Okay, sorry about that. It should be hugging the 8, which is what it is. So at this side, at negative 4 and 7.8, it's right up here by 8, 7.8, right? At negative 2, it's still right up there, just slightly below 8. At 0, it's at 5, so right there between 6 and 4. At 2, it's at negative 4, so clear down here. And then at 4, it's off the graph down here, like negative 40. You know, it'll probably be like somewhere down there. It'd be like negative 40. Okay, so when you connect the dots, okay, you can kind of see how the graph should look. This side, it's going flat, like that. Okay? All right. And then 1 over 4, this is the one that I was mixing up the numbers with, sorry. Again, you start off with your tables, negative 2, 0, 2, and 4. That's your x, and then you get your y's. 1 over 4 to the negative 4th power is going to get you 256. So clear off the graph, off the page on like 5 pages later. Okay, and then negative 2 is at 16. So that one's graphable. 0 is at 1, because anything to the 0 power is 1, right? Even 1 over 4. And then 2 is 1 over 16, or rounded to a decimal would be like 0.1. And then 4 would be like 1 over 256, which rounded to a nearest decimal would be like 0.01. Okay? Then when you graph it, Negative 4, 256, that's clear off the graph. So we're going to start with negative 2. Negative 2 is at 16, so clear up here. At 0, we're at 1, so down there. It's a pretty steep graph here. And then at 2, we're at 0.1, so we're just hugging 0 basically. So it's going to hug 0 going that way. And then when I connect these dots, I get a very steep graph going that way. Okay? Not too tough, right? Again, it's just graphing. You get your ordered pairs, you get at least 4 points on there, and you're generally pretty good there. Okay, now for the level 4 question. So here we have a graph that somebody's already done. Unfortunately, he made mistakes. Okay, so here's his table, here's his graph, here's the original equation right there. So we're going to try to figure out what he did wrong. So we're going to start by looking at his table of values and plugging in the same x values and see if we get the same thing. So he used negative 4, negative 2, 0, 2, and 4. So same thing we're going to use. So when I plug in negative 4 on this one, I'm going to get 7.9. So that's a little bit different from what he got, right? And then when I plug in negative 2, I still get 7.9. So he's getting really close to 0 basically on his. But we're up here at 7.9, close to 8. So I'm thinking he probably just didn't add 8 at the end. He did everything but add 8. Let's see if that's confirmed. So the next one would be 7.5. We're looking like we're just about 8 above all of his numbers here, right? Then the next one would be at 2, which is 3.5. Okay? And then the next one would be at negative 32.5, so off the graph. So it looks like he mostly did it right. He just forgot to put the plus 8 at the end of his equation when he was plugging it into his calculator. So when we actually graph it, the line would look like this. Negative 4, 7.9 would be right up there by 8. And then it would be right up there by 8 again. It would be close to 8. And then, it's hard to see because of the bleed through. Sorry, guys. Then at 2, it's at 3.5. So close to 4 there. And then at 4, it's clear off the graph. So these are the dots that I drew right there. So it looks like it's hugging 8 right there. And then it's going to go down like that. Okay? That is what it should look like, which is pretty close to what he has, just mine is shifted up 8. So his mistake was didn't add 8 when he plugged in X. And that's pretty much it. Okay, if you have any questions, ask your teachers. We're here to help. We want to help, and I'll see you out there.